Hi, this is Professor Fernandez. We're going to work on class notes D in lesson 17. In this class notes, we want to plot the direction field for the plane autonomous system x dot equals negative y dot equals x at the following 4 points. And we're only using those 4 points because to plot the actual direction field would take forever. So we are going to rely on this website, which I'll show you after we plot these 4 vectors, to give us a sense of what the full direction field looks like. So rather than doing what I usually do, which is just scroll up to the definition and try to explain it first, excuse me, for this particular concept, it's really much better for me to show you how to calculate these vectors. And then you'll be able to see how to do this for every direction field type problem. So what I'm going to do here is set up a table. On the left, on the first column, I'm going to put in these 4 points. So 1, 0, 0, 1. -1, 0, and then 0, -1. And then over here, I'm going to plot these points in the plane. So 1, 0 is here, and then 0, 1, there we go. You can kind of perhaps anticipate why I've chosen these particular points to plot the direction field vectors for. Okay, and then back over here, I'm going to, in the second column of this table, put the actual vectors that form the direction field for this system at these points. So what do? I take the system, x dot, y dot, and the vectors that are in the direction field for this system have the form x component negative y component x. All right. So this makes it particularly simple for me to calculate these vectors because the rule is simple and interesting. So the second component of all these vectors is the x value of the point. So I'm going to use that to my advantage. So this is x value 1, second component here is 1. X value 0, second component 0, and so on and so forth. Great. And then I'm going to go back and try to listen to what this vector is telling me about the first component. It's saying whatever the y value is of the x of the point that I'm looking at, multiply by -1, right? So change its sign, S-I-G-N. So I'm going to look at this first point here, and its y value is 0. Changing the sign is still 0. Oops. Great. And then I'm going to look at this y value, changing the sign is -1, change the sign here, and then change the sign there. So how do I piece this together, right, to make my direction field? Well, now what I do is I literally, on my Cartesian axis, right, the xy plane, I am going to go to my table on the left-hand side, and at this point, I'm just going to plot this vector. It really is that simple. So at the point 1, 0, that's right here, I'm going to plot this vector. How do I plot this vector? Well, I go 0 units horizontally, and I go 1 unit up because 1 is positive. So in other words, I just go up. So my vector is going to be straight up 1 unit from here. Great. And then I just rinse and repeat, right? So the second line in the table, I go to this point, I plot this vector. So how do I plot this vector? I go 1 unit to the left because -1 is negative, and 0 units up. So in other words, I just go 1 unit to the left. So I go back here, and I go 1 unit to the left. Great, and then I just keep going, 2 more. Down here, I start at this point, and then I plot this vector. I don't do anything horizontally, but I go 1 unit down. So I'm here, and then I go 1 unit down. And then last one, at this point, I go 1 unit to the right and 0 units up. So 1 unit to the right, 0 units up. And this is the plot. You know, you can sort of start to maybe imagine what the direction field looks like based on the plot of these 4 vectors. So what's one of the things, and we'll confirm this in a minute, what's one of the things this direction field, these 4 vectors might suggest? One thing that it would suggest to me is that maybe there's some circulation in this system, some counterclockwise circulation. So maybe things are going around and around in that counterclockwise direction. So I don't know. Maybe that's true, maybe it's not. We've only plotted 4 vectors in the direction field. We could plot more, but that will take a while, and it might still not give us the information that we're after. So that is really the point of showing you this website and showing you how to use it. So I'm going to transition over to the website now. I want you to take a mental snapshot. I mean, I guess you could rewind this video, but take a mental snapshot of what we've seen here, right? This counterclockwise circulation. Now that we're going to leave this file. Great, so I'm going to go over here, and I have put in on the upper right hand side right here, I've put in what the x dot is, I've put in what the y dot is, and then over here, if you open this up, I've set it to Runge-Kutta 4. So this is a fairly, pretty actually very accurate numerical solver, numerical scheme. When you first open this up, it's going to be set to Euler, which is a very quick way to have the computer, or in this case iPad, website, estimate the direction field parameters. And so do it very quickly, but it won't do it particularly accurately for a lot of systems. So Runge-Kutta 4 takes a little longer, but it is actually much more accurate. So I would change that. And really, there's not much to do here. You can see on the right-hand side the vectors that we have plotted. On the x-axis down here, you see that there's the domain is x goes from -4 to 4. So we can change that over here, and we can go from -1 to 1. So we can kind of get a better sense of the numbers that we used, and same thing for y. So let's go from -1 to 1. Okay. There we go. And then I'm going to bring the keyboard down. So you can see on this direction from the right-hand side, this indeed counterclockwise rotation that we had picked up. So very close to x equals 1 and y equals 0, you see the vector going straight up. So I'll explain this curve in a minute. On the other hand, on the other side, very close to x equals -1, y equals 0, you can see the vectors going straight down. And then at the very top, x equals 0, y equals 1, the vectors are going to the left. The very bottom, x equals 0, y equals -1, you see the vectors going to the right. Those are the 4 vectors that we plotted in the lesson notes. But this applet gives you obviously much more vectors. So what is this red curve you're seeing? Well, if you were to plot all of the vectors that this website has plotted, and then you just kind of started anywhere in this plane, and you followed the vectors around, the red circle, ellipse, we're not quite sure what it is what you would obtain, right? If you connected those dots, if you will. Again, we'll talk about this concept later in the lesson notes, but the point of this video was, again, to introduce you to direction fields, and specifically how you would use this website to fill in the additional vectors in the direction field after you've calculated a few of them.